Hello there, we're going to look at complex numbers again, but weirdly I'm doing loci. Now last time you probably saw loci was when you were doing GCSE maths, and you probably saw some loci, how much you understood of it. I've got one on the board here. It says perpendicular bisector, and there were others, angle bisectors for instance, spring to mind. So how much you remember that, as I say, I don't really know. I'm going to assume nothing, so let's get on with it. So a little starter for you initially. So I want can you write down a complex number for me with modulus 10? So pause the video and have a think. Okay, well, I mean, I don't know what you've done. Look, can you write me another one down? So I want a couple of them. And I think there's 4 pretty easy ones you could write down. So write all of those down for me. Okay. Look, I'm hoping you've done those. If you haven't, pause them quickly before I show you. But my first thought was I could go 10 straight across. So now that would be z equals 10, but I could go in any direction, I was thinking, so I could go up as well. And that would be z equals, now it's going in the imaginary axis now, so that would be 10i. But I could go down instead, so I thought z equals minus 10i, and likewise I could go left. So that's what I mean by this. There's 4 pretty easy ones straight away. But look, I want more, be more adventurous. See if you can find me one in one of these quadrants. Probably in this quadrant it's easier. So pause the video and have a think. Now, alright, and so hopefully you've thought of something. Now I was thinking I need to make 100, but when I do this, really what I'm doing is I'm going to do a bit of Pythagoras, I suppose. So if that's 10, then I'm thinking 10 squared. That's 100. That's where I'm getting 100 from. So if I think of 2 numbers, I don't know, like 80 and 20. It's just completely made up. Root 80 and root 20. When I square them, I'll get 80 plus 20. When I square root my answer, I reckon my answer will be 10. So just made up numbers, I reckon root 80 and root 20. Now, if I plot that, it's around here somewhere probably. It's not quite as, it's probably about there. And you might have thought of your own one. And if we plot them all on an Argand diagram of all the possible ones, I think we'll end up with like this situation occurring. I think it'll be on a circle. So for instance, I could have picked minus a number, minus 80 plus 20i. If I wrote that instead and found that well, that would be over here, you see. That'd be there, or I could have picked one there, but then it's there. I think they form a circle. That's really what I'm trying to get at. I think they form a circle when you do this. So what we end up with is this idea that if you ever get an equation that says, do you know what, the modulus of this complex number is equal to, say, in this case 5, I think it's got to equal a circle. So that's what my picture will look like. And this would be described as the locus or the loci. Locus is just there's one of them as opposed to more than one. It's a plural or singular kind of scenario. But the locus of this equation, mod z equals 5, is a circle. And it's a circle of center 0, 0, radius 5. And look, here's another one. Draw a new sketch. This time it says draw the loci for mod z is greater than or equal to 5. Well, that's a bit weird, isn't it? Because I've said before it's equal to 5, but well, let's have a think what this means. Now, when it's mod z equals to 5, it's just a circle around here. But mine says greater than or equal to 5, so I think this is everywhere beyond the circle. So how best to draw that? You're going to have to shade it in some way. So there's my... So this is mod z is greater than or equal to 5. And this is now the locus, and this is what we're meant to draw. We are meant to draw the part of the graph which is more than, and this is really all it's saying, the distance from the center is more than 5, whereas this one says the distance from the center is equal to 5. That's why it's just one single line. And you can imagine that if I'd said mod z is less than 5, well, let's draw that. Now actually it doesn't say it's equal to. I actually deliberately wrote that. So I'm going to draw this with a dotty line because it's not allowed to equal it. That's 5 away. Where is it less than 5? Well, the distance is less than 5 away from the centre. So that's anywhere inside the circle. So this is what we're playing around with. This is a more complicated circle now. It's still going to be a circle. It says z minus 3 plus 2i. Now this is sometimes written z minus 3. I suppose it would have to be minus 2i if you write it in brackets like that. And it says the distance is 4. Now this is almost like transformations of graphs. No, have a look at what the answer is. This point here is 3 plus minus 2i. You see it 3 and minus 2. What I wrote in brackets there, I've effectively changed the sign, a bit like you do with transformation. When it goes in brackets, it's the wrong way round. So it's gone minus 3 plus 2i, and I then wrote that as z minus 3 minus 2i in brackets. But notice my circle has no longer got the centre there. It's the centre is at 3 minus 2i, at 3 minus 2. Its radius is still 4, but interestingly it's 4 from this new centre. So in any direction that is 4. This is what you're meant to be able to do. It's a circle of centre 3 minus 2, radius 4. So on the new sketch it says draw this, which is less. Alright, so it's very similar to the last one. It says draw the locus or loci for this, and again that is minus 3. You always change the signs if it's not in brackets. So I reckon it's down there again the same way as before. It's a radius of 4, so it's exactly the same. Let's make it look as if it was in the right place. So that's 3 across, that's 2 down, and it says it's less than or equal to 4. Well, the fact is that equal means I can draw a solid line, which I have, and I just shade inside the circle, because the distance from the centre, the distance from this centre has got to be less than 4. And this is what you're meant to draw. You're meant to probably label the imaginary and real parts on your axes, but that's what the picture's got to be. More argan diagrams. Let's look at another one. Oh, right. Task 1, you're going to do this sheet. So in class I'll give you out this sheet and we'll have a look at that and see if you're any good at them. We'll then go on to loci number 2, angles. Now angles is really a posh way of saying argument. We've already seen this word argument for an angle. And it says the argument of z minus 2 plus I is pi by 4. Now again, pi by 4, I want you to remember pi equals 180 degrees. So if I divide it by 4, that's the same as 45 degrees. This is going to be a 45 degree angle. It says the argument, again, I've also said to you that sometimes you write these in the brackety form. So I've written arg z minus 2 minus I. You might prefer that, you might not, I don't know, equals pi by 4. Let's draw the picture. Interestingly, it says 2 minus 1i, and notice what I've done. I've gone from the centre, I haven't done it at the centre, I've gone 2 across, 1 down. And that's where my angle has started, because I know arguments are really angles. And it said pi by 4, which I know is 45 degrees, so I've drawn a 45 degree angle. This line actually carries on forever and ever and ever and ever, but eventually you give up, you get bored of drawing it. I've shown this then, it's an angle drawn from 2, minus 1, at an angle of pi by 4, to this horizontal line. And I like to draw this horizontal line as well to show it. For instance, then I might have this one, arg, I'll just make it easier, arg z equals 3 pi by 5. Now I don't know what 3 pi by 5 is. It's certainly bigger, I think. I'm going to type in, what is 3 pi by 5 equal to? 3 times pi divided by 5. It's equal to 1.88. And you might recall that I said 1.57 is the magic number, because that is pi by 2. So that tells me this one will look like this. It will go, it'll be an angle pointing kind of like in that direction. And in actual fact, because it says arg z, it doesn't say this funny thing here. It just says arg z. It will go from here, and it will go up in that direction. And that's what you're meant to do. And there's my angle there. Oh, I wasn't going to do that one, so let's get rid of that. just so that I can see what it actually says. Result. There. Luckily it was still there as well. Now this, it says draw this, and it says draw on a new sketch, also draw the loci for the alright, now it's the same thing as I drew over here, but now it's between 0 and pi by 4. Now it's not equal to pi by 4, it's saying it's between 0 and pi by 4. Well, again, you just draw what we had before, because it's the same thing. It's at 2 minus I. So it's there, that's the 2 minus 1 bit. So I'll just show that as 2 comma minus 1. And I draw the dotted line. I'll draw my angle at pi by 4 degree, radians. And my angle, my argument is in between them. So I have to sketch in between these things. Oh, and actually I've done it slightly wrong. I've just realised. It says it's got to be less than pi by 4. So that angle there which I drew was right, but it should have been really a dotted line like that, because it can be anywhere between it, but it doesn't say it can be equal to it. So task 2, we've got a angles sheet to do, and then we've got this thing I've called 2 circles. It's not really called 2 circles, but I'm drawing 2 circles to show you what's going on. It says draw the locus of z minus 2. Now last time we had z, for instance, plus 1 minus I, which is what this one said. The modulus of that equal to a number like 3 would have been a circle. Minus 1, I reckon, you change the sign, I reckon there, it would have been a circle of radius 3. Now, notice what I'm doing here then, that is my circle of radius, whatever, that is that one. And this one says z minus 2, so minus 2, it doesn't say any i's at all, so it just goes straight across. And I've said, look, it just says here in this question that this circle's distance from the centre is equal to this circle's distance from the centre. And I just imagined 2 circles. I don't know what I've done. It's like 1 and a bit radius. And this one's 1 and a bit radius. It has to be, because the 2 circles have got to be the same size. This is what it's saying. Both circles are the same size. It's a bit boring, they don't cross. But if I make it a little bit bigger, they do cross. So this time this one's equal to exactly 2 across. Exactly 2, a radius of 2. And now they cross. You can see where they cross, here and here. And I don't have to have those 2. I could have those 2 instead. So now they cross here and here. And in fact, I could have them cross in any number of ways. You know, here you've got them crossing there and here. But you start looking at this and you think, a bit, where they cross is actually quite interesting. Look at that. Look where they cross. What do you say about that? You say, it's a straight line. And that straight line is called the perpendicular bisector. It's the perpendicular bisector of these 2 points here. So if I was to draw a line joining those 2 points up, and draw a line at right angles to it, this is why it's perpendicular. That line is the loci. Now I'll be honest, that's normally all you draw. You normally only ever draw the loci, and maybe the points join, the line join them up. If, for instance, it said, on the new sketch, I'm going to use this one because I'm lazy, draw the loci for z minus 2. Now remember z minus 2, that was this point here. That was minus 2, and the other one was that. Okay. Draw z minus 2 is more than this. So the distance from z minus 2, the distance from there, is more than the distance from the other circle. Well, I think all it does is it says it's got to be on the left-hand side of that line. It's got to be further away from 2 than it is from here. And I think it's probably meant to be a dotted line, because it doesn't say it can be equal to it. And we have to draw these sketches as well. So our final task in lesson will be to have a look at perpendicular bisectors. And we've got a sheet on those as well. And that's really all we're going to do. So just bear that in mind. There are 3 to do. The perpendicular bisector sheet. There is the sheet on, eventually I'll get to it, on angles. That's task 2. And there's the initial sheet was more on our diagram sheet, which was basically circles, and you have to answer some questions on circles, and in class we'll do all 3 of those. Okay.